Hello everyone, really nice to be here, and thank you for coming to the session. At the moment I'm struggling a bit with internet connection because I have online version of the slides, and speaker Wi-Fi network is not working here at the moment. Yes. Yeah, so we have very limited amount of time, so let's be very effective, efficient, and yeah, let's make fun. So today we are here to answer the question how to create Angular applications which load it faster and fast, and also good in code execution, right? Why do we need it? To make our customers and ourselves happier. About me, most likely the most important part for you from this slide is my Twitter handle. Why? Because I will post the link to this slide deck right after my session, and it contains some code samples and many links, many references to other great articles. Yeah, I run NG Vikings conference, so by the chance, maybe anyone visited NG Vikings this year and last year? Okay, only me and you see. We have to visit because we are organizers, right? So, today, let's build our session in the form of a cookbook. So, I don't call this checklist, like performance checklist. Why? First, because Minko Gechev already called this checklist. That's a joke. And second is it's not applicable actually to every Angular application. So most likely you don't want to go through all the points for your every Angular app, because some of them are quite specific to some use cases. So it's important for you to know how this or that recipe works, how to at least start with this, and of course how to get more information. And I will try to build discussion in this way. So in general, web application performance, what is this all about? It's about physical limitations we have. First, network, and we just experienced this 2 minutes ago, right? This is very important part. And of course, we run our app, our service on some device, right? And these devices would be quite constrained in terms of performance. So, in the largest picture, what do we do with network bandwidth? We try to make our bundles smaller, right? So this is just very first approach. And about device, we try to make our code better. In a wide sense again. So in the best case, to deal with network bandwidth, we just don't use network at all, right? So this is our dream. And about the code, our dream is to not run any kind of code. So this will be the fastest option. Let's go into detail a bit regarding network stuff. So what can we do here? Obvious, we want to make like our overall bundle or bundles smaller, right? If we go a bit deeper, most likely we need split them up somehow. Why? Because at the first load, they don't use they physically cannot use full potential of our cool app, so it makes sense to deliver only what we have to deliver. And last but not least, as I mentioned, it would be really cool to cache as much as we can, of course, with following some rules, right? Not to always deliver stale code. And based on that, first recipe is actually not even the recipe, right? It's just a reminder. Let's use production builds for our apps, and this is here because you cannot imagine how many serious Angular apps on the network with development mode inside. What does it give to us, this dash prod, totally without any efforts from our side, totally out of the box, thanks to continuous efforts of Angular CLI team? First, actually, prod, this is so-called meta flag. This is not a real flag, but a flag affecting a set of parameters for our build. First, we use ahead-of-time compilation. It's easy to say that, okay, we don't ship Angular compiler, we don't ship HTML templates, we try to do as much as we can during build time and ship like ready-to-go JavaScript code. Of course, it sounds really, really simple, but believe me, there was a huge job from Angular and Angular CLI team to introduce this. Next level of optimization is so-called build optimizer. On that step, we try to eliminate that code and do tree shaking as efficient as possible. Again, behind these two simple and marketing-ish looking words, there was a huge job. And if you remember, it was not enabled by default in the previous version of CLI, because it might happen that something will go wrong with your project, but to be honest, I can't come up with a use case when it can make something wrong, but anyway, you can disable this. Next, we have Angular Service Worker enabled, and in general makes sense only in production mode. A bit later about this. And going ahead of time a bit, I can say that this flag enables via environment settings so-called prod mode, which is extremely important to have. I will focus on that a bit later when we switch to code execution optimizations. Okay, so first how-to of this recipe is not even how-to of the recipe itself, but how to check how good Angular CLI is in this optimization. There are two tools which work really similar. One is Source Map Explorer, second called Webpack Manual Analyzer. So this is just one of them. With running a couple of commands, you got this nice picture. Of course, no reason for you to understand what's written here. It's just name of corresponding bundles you have in your overall bundle and its size. And thanks to this, you can find some unused ones, me found one component from Angular material which I never used in the app. Okay. Next, let's split our bundle to sub-bundles, right? Our goal is to download everything we need and only what we need during the application start. And let's talk about later what will happen later, right? What possibilities do we have here? So first, we can control what we can load and what we can't load. So this is quite often use case when you use lazy loading and some admin parts of your app. So instead of can activate guard, there is a special one called can load, specifically for this asynchronously loaded modules. Okay, we have our first load experience very fast and good. What's next? When we click on some links in our app and want to download new modules which are not part of this first bundle, of course network delay will happen, and maybe this is not what we want, right? This is why we can preload everything, right? So, but it's important that this will happen only after first successful navigation, which could be like navigation to our initial page. So no worries, all these downloads, all these extra ones will happen in the background, say without serious interrupting of user experience, like only networking, right? So this is all or nothing kind of idea. Preload all, or how it's called, other strategy called default or known, when we preload nothing, right? No, we can control this in absolutely granular way. when we use our custom preloading strategies, when we can say we want to preload this bundle and don't want to preload this bundle. So I'd say lazy loading implementation in Angular 6, and it's in this shape approximately from Angular 4, is like the easiest one I can even imagine, right? So again, simple methods are covering quite complex under the hood work job of framework. How-tos. Quite simple. Instead of importing our feature module, which is in my sample tweets module which loads list of tweets, we just reference it in our routes as load children. Quite easy. On its turn, in routing module of tweets module, we can have our own navigation, which will be sub-navigation. So if we specify in this path something like card, then after typing or clicking to tweets/card, we will load specifically this component from our lazy loaded module. Awesome. Preloading strategy is also like one-liner. So in your main routing module, you specify preloading strategy, which is all modules. Cool. So we can very detailed control what we load, but we still have to load something, right? What about our dream about load nothing? That's possible, of course, on the second load, right? Yes, loadless apps are not invented yet. And instead of giving how to we start straight away from this. So there is a really cool feature of latest Angular CLI, or it's not even feature of CLI, it's just a general new possibility for, I believe, all frameworks, right? Called schematics. And by running this command and we add Angular PWA, we scaffold all we need to build PWA progressive ABAP from our app. But don't forget to run production build again. So it all will work only there. So what will happen after we build this app? First, we'll have app shell. In a few seconds about this. Next, we have the possibility to optimize actually 100% of requests we do from our app. Web app manifest is a nice, say, extra feature. It's not about performance, it's about making our web app as an app. But okay, what is application shell and what it gives to us? Quite a straightforward idea. On the first load, we take all we loaded and put it into some special storage to serve it from there later. It's for online. What about offline? Absolutely same idea. If we have something in our storage, we can deliver it straight from there. This is why this is how Service Worker provides offline experience. This magic new feature of the modern web. In super simple words, just 30 seconds, how it works. How does it work? We have our app, internet, and in general, our requests go like this. If they put Service Worker into the flow, it can decide where to go when. You may ask, okay, so Service Worker, this is JavaScript file, how do I write it, create it, right? In Angular, you don't care about this at all. Once you install this Angular/PWA schematics, it will install Angular Service Worker for you. And you just have to provide some configuration for this. Two main options in this configuration. First, to provide app shell, to let Angular know what specifically to cache. There are already some smart defaults for you, so right out of the box you have offline version of your app up and running. Data groups, this is about second feature of Angular Service Worker, optimizing requests we do to APIs during application run. Again, one minute, about very basic configuration of these data groups. In general, we specify some pattern of our URL. It could be our API or some third-party service, and provide a strategy. At the moment, there are two strategies, which are performance, when we try to reach network, when we don't even try to reach network, when we are good, for example, for archive, right? We don't, if you have something already cached, it's good to show. And second one is freshness. Maybe for kind of API/breaking use, this one will work better, right? So it sounds like really a great new world of progressive web apps, service worker, etc. But you have to keep some things in mind. It's really related to what we are talking about today, optimization, right? So first, service worker downloads assets of our app again after it started. So on the very first run of our application, our users will get our app assets, index.html, JavaScript, CSS, maybe some pictures twice. So this is kind of trade-off of how it works, right? So we cannot intercept before we register, right? Next, on the second load, if you were lucky to update the app version on your deployed location, most likely users will see still the first version of our app. Again, one more well-known trade-off of progressive web apps in general. Why? Because of idea of application share. We try to serve everything from cache first. There are more alternatives to Angular Service Worker. For example, one called Workbox, which maybe it doesn't give you so well smart defaults right out of the box for Angular apps, but in general it's much more extensible. And compared to all other techniques we will talk about today, it's applicable only to as a progressive enhancement. So we cannot rely on this. But on the other hand, current support is quite good. So no worries. Next, server-side rendering. Here we came to the point when we had a trade-off between network and code execution time. Why? Because here, by intention, we load a bit larger bundle of our HTML, but on the other hand, we can show something to our user immediately. So let's illustrate. Regular way, we load some HTML. Most likely we have something app root and loading inside in index.html. We bootstrap our app, and only then we see something meaningful, right? So this is what's important. But before that, we see blank page, white page with loading if we injected this in app root. If we fix this, if we do all this bootstrapping on our server, we load HTML, so you see it's a bit larger. I was honest with this. But on the other hand, we have this first meaningful paint right here, because what we deliver to the browser in this index.html, not just uproot loading, but actually bulky, dirty set of HTML and inline CSS. It's bulky for us, but this is exactly what browser loves, right? And then we can do all the rest. Okay, so what gives better first load experience? This is a point where we really struggle for each millisecond, and there are lots of articles about this. Next, good idea to, when you share your website with some social medias, most of them cannot do this bootstrapping or automatically, and this is why instead of seeing screenshot of your app, you see something different. Right? Last but not least, better for search engine optimization. Again, it maybe not very applicable to Google, because Google search engine is quite good in doing in running single page applications like in Spider itself. But anyway, it's always better to have full control on that. How to do this? There is a long way. Again, using Angular CLI, you generate corresponding project and then following this guide. And this one is quite extensive because the whole idea is not very simple, right? You have to have a node server where you run your Angular code on the server side, and then you push it to the client, and then you push the rest of scripts, and then scripts take control on this. Much simpler. Friend of mine, Maciej Trader, created one more schematic called ng-toolkit/universal. You run this command, and you can at least taste this server-side rendering. Maybe it's quite opinionated, but still, this will most likely work for your configuration. Awesome. So now it's time to move next to code execution part. So we are totally good with networking, and if someone will introduce starter or schematics of server-side rendering plus service worker plus lazy loading, I'll be extremely happy. Yes, and if you know this, tell me, because the one from Maciej, it contains server-side rendering and service worker, by the way, from the workbox, but there are some issues with lazy loading. Okay, enough about network, right? We got our code in the browser. Time to run this. We have to constantly deal with change detections optimization. So actually, this is main consumer of CPU power in Angular apps. We trigger some event between UI is ready. There are some steps. First, Angular processes all event handlers, then and goes from bottom to top. Then from top to bottom, it processes data bindings. We call all this change detection itself, and after all, we render our DOM in the browser. And the problem is we have only 17 milliseconds for all these operations. Why? Because it's considered that if we have 60 frames per second, it feels natural. So if less, you see some lags. Good. Okay, so we can have some strategy here. First, let's make each change detection faster. Let's reduce number of change detections. And of course, if possible, we have to render DOM as few as possible, because this is a very expensive operation. My first advice, use pure pipes instead of methods in your templates. So just imagine, in our list of tweets, we have date of this tweet, and we want to create a relative date from it. Relative, what it could be like 1 day ago. Also, just simple date calculations. And there are two options to do this. Use method from our class, or use pipe. The problem is, this one calculated on every change detection. And the second one will be processed only if date is actually changed, right? Let's illustrate this. This is how my test app looks. And on each big red button click, we see more and more calling of this method in template. On the other hand, if we switch to the pipe, to the second option, again, big red button, clicks, 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 no change detection. Why? Because once we calculated it, this source for these dates is not changing. Why to use our pipe? How to do this? Using Angular pipes. And by fact, all the pipes are pure, which means like they're pure functions, right? I just put it here to emphasize that it has to be like this. So we just implement our custom pipe based on pipe transform. We can go even further and implement memoization. Why to calculate dates, these relative dates for the dates which are the same, right? Even inside one list. If you go with like regular pipe, you will calculate every date in the list. But if you apply memoization technique, you will see that bam, on 5 calls of pipe, we didn't trigger the method inside this pipe. It means it was kind of cached in our memory. No reason to implement it by hands because we have really cool library called Lodash and cool plugin to this library called Lodash Decorators. So you just add this decorator memoized to any function, and it works like magic. If you wish, you can use like more classic approach and call this without decorators. Next, recently on push strategy. There are many articles about this, so this is my view. Change detection happens each time something happens, like click or feature request or timer, for all component stream, without exceptions. But this is by default. So let's just imagine we have happy components, and one became very happy. Something happened in this, like someone clicked something inside. Wow, we propagated this event to the top, good, and our root component started to do data binding for all the tree. But these folks, they are not taking part in this process at all. Why to bother them? So let's keep them happy, right? Let's say it like this. Luckily, it's quite easy to implement again. So you just specify change detection strategy for your component, which is on push, and then change detection happens for this component only if reference of the object in input changes, or event happens in this component or its children. It's also important addition, or we can run this explicitly. Unlikely it's cut, but this is really important. If you use async pipe to string your data to your templates, you don't have to care about this, because this will happen something like automatically for you. So no need to use some like extra techniques like immutable.js. Let's illustrate this. Okay. Let's pretend that this big red button doesn't have anything related to list of tweets we load, and it is actually. Why to run change detection each time we click this button? I don't have any idea. Let's switch to on push, and voila, we click this button, and nothing happens in the list, which is good for us. Less code to run, 0 code to run, better. And by the way, there is nothing specific in the handler of this button. This is just empty click handler. This is just to emphasize that this change detection happens so many times under the hood. And last but not least, let's create our own schedule for change detection. For example, if we have crazy super real-time data like from WebSockets, and it updated many times in a second, we just don't want to have this on our UI, so we can disable this for a component. And on the other hand, we can run something inside our component which doesn't trigger this at all. So first, how to disable this? We have change detector ref for our help. So on constructor, we just detach this and do checking manually on some timer, like in my example, for example. So we have all the methods here. Detach, also we can reattach later, and all to run this manually. How to run outside of Angular? For example, do some logging where we don't care about the changes that will happen. We just use ng-zone special method called run outside Angular. Good, let's summarize what we learned today about networking. We learned about don't forget to use production mode, use lazy loading, service worker. This one is something intermediate actually between networking and code execution, where we learned this stuff. Thank you very much. That's all from me for today, and I will be there.